Hello everyone and welcome to yet another live stream, and today we will be doing some Blender stuff. That's it. That's the entire thing. Blender stuff. Now, let me just screen main. And I will not lie, this will be for a video. Obviously, I'm multitasking right now. I'm doing streams and videos at once, because I'm behind. Alright, great. Now, I can go back. There we go, screen. We will need how many things? After I'm done with this, we might do also paper. I have time until... I have 2 hours for this stream, so should be decent. Oh yeah, I'll have to ping. Yeah, we'll ping. Just first, we will need 2 files. We'll need 2 files and we'll... Okay. New, let's call that folder, and we'll have first one light. There we go, and the second one, which will be touch. And these will be particles, don't worry about that. Open recent light. There we go. In this one I would like to model how light interacts with particles, which might be something. It will be something. Let me just... My taskbar for my second screen isn't working for some reason. Well, it isn't working because it's Windows, and nothing's quite working on Windows. At MKT, church streams, at streams. Nothing exciting today. There we go. Nothing exciting. And let's just screen main. There we go. So what we'll start with is just an atom. Now nuclei. I'm pretty certain that's what's spelled, I think. And electron cloud. The reason why we're doing this is because, well, mostly because of the script, but also because it's actually quite interesting. How do electrons... No, photons, I'm sorry. Photons obviously reflect off atoms. Because it's not as simple, it's not they just reflect. I mean, over here we should have a graphic for this, right? This graphic. There is... Yes, that's what it looks like. And it's kind of insane. I mean, every single time a photon is reflected, that's what happens. This right here. An electron is just bumped up and down. The problem is that we are modeling electrons as electron clouds, which basically means that... Whoa, will it be a crash? No, it wasn't. That was close though. I have some issues with crashing because I'm still rendering something for another video. Now, over here, remove this one. Principal volume. It's really messed up. I don't know if you can see it. For some reason it's really messed up. Huh. Well, anyhow, this will be an electron cloud example, and color doesn't matter. We'll have emission strength of 1, and it will be like this. Now, actually this graphic, actually this animation might not be that hard to show, so we will probably just focus mostly on... Mr. Man, you really went for it. Yeah, this live stream will not be interesting. I'm very sorry. The one live stream that you actually... that actually the ping worked. Well, that I did a ping. Side thing, it seems, is actually a boring one. So I'm very sorry about that. Tomorrow there'll be I'll do a GTA live stream. That would be much. You know what? Tomorrow I'll do it around the same hours, so that would be easier. Because for now I'm just doing no. Now over here. There we go. Now. You do will be boring. Oh, you underestimate my powers, my friend. Ha! Just watch. Oh boy. You underestimate me. So. You really underestimate me. Okay. I have to get. Okay, I cannot. This is too much even for me. This is too boring even for my live streams. So instead, I'll switch some time, because that was modeling that is too bad even for my kind of stream. Instead, let me just open up the source, the resource source for space, time, and time. Because last time I haven't finished the thing. There we go. If I'm not mistaken, 114. Oh, I'm good. Yes. Oh, damn, I'm good at this. At remembering single numbers. I'll be back though. Don't worry. It's fine. I'm not doing anything. Okay, here. Bonds. Yes. So last time we did bonds. James says. Now. Bond between two particles. So this is a general rule of bonds. Protons repel, electrons are attracted to protons because of negative charges. That's the general rule of bonds. Ionic bonding, and over here we have models for them. Ionic bonding and covalent bonding, which was the one we didn't finish because over here it's explained terribly. It is. So instead, we'll add 3 models. The polar covalent model, the Coulombic model, and the VCEPR model. Now, like this, but at the same time we should go to wikipedia.org and go for covalent bond. Yes, because Wikipedia just has a better explanation of what the covalent bond actually is. Over here, if you read into it, there's an example which looks like this. But a covalent bond, that's the co, the name co, valent is the valent electron, co means, well, both, right? That would be, I suppose, a decent translation of this. So covalent would mean both electrons, a pair of electrons, as seen over here. Over here, though, you can clearly see there's only one electron, so that's not that great of an example. Now, sharing of electrons from electron pairs between atoms. Yeah. No need for bold. Covalent bond occurs when atoms share pairs of valent electrons. To form electron pairs. I totally misspelled covalent here, right? There we go. Electron pairs, which these ones I do believe should be like this. There we go. Now,
Stable balance of attractive and opposite forces between atoms when they share electrons is known as a covalent bonding. Yeah. So this is important organic chemistry, because ionic bondings are require ions, right? So obviously. Now, there's one thing I was always interested in, never got an answer, because these things are stable when there are 2 or 8 electrons, 2 or 8 valent electrons. Why? Full valence shell. Full valence shell. Okay, we should probably finish electrons then, right? Over here we should have valence electrons. Alright. Is an electron in the outer shell associated with an atom? Are electrons in the outer shells associated with an atom? That can participate in the formation of chemical bond? Yeah, but that's kind of obvious based on what bonds are. If the outer shell is not closed. Yeah, okay. In a single covalent bond, we should probably add this to the sources, right? Because I will actually use this more, not just for a different way to find things. Now, citations. Add citations to website. Continue. It's a corporation. Wikipedia. There we go. Sick. Shit. Or maybe valent electron. That probably could also. Oh, valent. Valent electrons. Wait. Valence, because I feel like valence would be different than valent in this case. It's valence. Well, basically the basic idea is simple. When you have atoms, there's a certain number of electrons on the most outer shell, which causes them to be stable. The more electrons they are missing, the more reactive they are, because the more they want to be stable. Nature has this thing where basically it loves when things don't have the energy. Well, when they are in their lowest energy state. So they want to achieve this number of electrons. Alright. Group D. These. Well, that's a note to remember. The valence electrons don't have to be on the outermost shell. Yeah, right. So, valence electrons. Okay, so I've got nothing. I've got nothing so far. Core addiction, that also seems like a reasonably important thing. Absorb or release energy in the form of a photon. Yes, that's actually kind of cool. That's actually kind of sick, because that's how vision works. Because atoms don't reflect photons, electrons absorb them and then release them again. And can even break free. Ourselves. Okay. To be fair, that's just the beginning, the thing. Number of valence electrons, so what's their blocks? This part of I know about you. When I was first studying this, I learned there's no rule to it. Or at least no one taught me a rule. I remember I came up with a rule for myself, but it was kind of a model thing for remembering all of this. Periodic table group. Yeah. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 3, 4, 5, 6, 7, 8. Except helium. Okay, I'm pretty certain it looks like this. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They just... Okay, there will be 3, 4, 5. The lack of rules is just upsetting. So S has 1 and 2. F, which is group 3 to 12, have 3 to 12. F, which is... There's absolutely 3, 4, 5. Okay, so I'm guessing these ones are. No idea. Well, what? But that's. This. Okay. There is no rule to it, I understand. It's just we observe them having. That's very upsetting, because I feel like there should be a rule. Rules for how many valence electrons an atom has. There has to be some sort of rule. Prefer to have 8. May I know why? Oh, that's library! When atoms are fewer than they tend to react and form more stable compounds. Okay. So, the carbon hydrogen example, yeah, it's everywhere. No. Okay. So what we should do is we should probably electrons.
we'll need this. These are the orbitals. I don't know, it started for this. I need shells. Yep. And here we have... no, I'm looking for... Obviously it's the azimuthal quantum number. What else could it be, am I right? Hi, Mr. Man. Welcome back. Obviously it's the azimuthal quantum number. We all know that's the azimuthal quantum number. I mean, come on. Who would know that's the azimuthal... What in the actual is the azimuthal quantum number? This is the part where the quantum physics really kicks in, which may explain the lack of rules. Wait, there is a rule. Oh, that's a beautiful visualization. Okay. So over here we can see how they increase. 288. But that's... And then you go away. So the octet rule is a thing. And atoms love that. Makes them non-reactive. Symmetry, actually, I never knew that, never went that far. Alright. So I'm saying that all the electrons in the shell have the same energy. This is an approximation. What's the level of energy? The other ones, okay. Proceeds from energy, high energy. Madelung rule. Finally, we got something. This is the rule, and it looks very beautiful. It's a very beautiful graphic. I love that. The only problem is that that's it, apparently. So these ones are the lowest energy. Ground state of an atom. Electrons always occupy the lowest available energy sublevel. So that's what it means, right? Elements is unreliable for elements higher than element 20 calcium. Why the exceptions again? Orbitals and neutral electron become too complex to be summarized in one simple rule. Okay, fair. That is pretty fair. Then we have this. I'm guessing that there is a rule for all of them, but it's just a massive differential equation, different for every single atom, so probably shouldn't dig that deep. Okay. I'm bad multitasking. It's hard being funny and understand this, because it's a lot of abstractions. The thing is, there is one rule for all of this. There definitely is just one rule for explaining all of it. The problem is that this rule will be extremely complex. It will be, as I said, some giant differential equation with explaining how every single election is dependent on any other election, position of any elections, yeah, it would be a mess. That's my point. So I get why the abstraction is present, but at the same time I have the right to be annoyed. Fills in the fifth period, fills in the second, at the sodium element 11 to copper element 29. Okay, we need periodic table on the side to actually make sense of why that is crazy. So that's the K. Then we have the L. Damn. M shell starts at sodium and finishes at copper, which is over here. Okay, okay. N shell starts at potassium. No, wait.
There's a guy named Jones, lab man. He makes prints of films. He handled this print.
Potassium before, right?
There's Smith.
Wait,
He's a
what?
film distributor. He sent the print to the
Yes, potassium is before. Potassium.
and Brown. He's film director at the station. I know. You're trying to make me the ball guy.
Ytterbium.
Projectionist at the station. I only had that print long enough to thread her up.
Not yttrium. Why yttrium? Maybe. This is madness. This is insane. Over here. This is insane. Okay, organism is the last element because that's where. But for now, this is the last element here because. Oh no, they are not complete, even the organism. Okay, so. The best thing to do at this point would be just add every single atom and explain its structure separately, I suppose. Because I mean maybe it's maybe maybe I don't. Huh, that's a. I genuinely think this might be a way to do it. Because there are no rules. This is too complex to have a rule.
My job.
This is insane. Okay, Avo principle. Yep, substance. Yeah, okay. So they first fill the load, which is reasonable. That's physics likes that. Physics likes when there's no potential energy. So that's good. First subshell is filled before the 2s. The 1s subshell is filled before the 2s subshell is occupied. Yep.
We're stuck with a perfect crime.
Swayed electrons of an atom. I am formed most stable electron configuration. Example is the configuration 1s2, 2s2, 2p6, 3s2, 3p3. The phosphorus atom. Okay. Yep. So they first field, yeah, they're very nice. This shows us that this is the case with 1s, 2s, 2p, 3s, 3p. 1s, 2s, 2p, 3s, 3p. Yes. Good. Great. Reasonable. Very reasonable. Very reasonable. If multiple orbitals of the same energy are available, electrons will occupy different orbitals. Same spin before any are occupied doubly. This sucks for many reasons. The fact, this entire thing. I mean, I knew that there wouldn't be probably a nice way to describe it, but at the same time, I can't hope. Okay. Great. Okay, that's the end of the page. So, obviously they are exceptions to the rule. Palladium. Obviously there are exceptions to the rule. Palladium is before silver. Over here. Yeah, as we can see, it does not follow the rule because we should go and screw ourselves. Okay, I feel like I should at this point create a separate chapter for atoms, just explaining every single atom separately, because there is no point. Grouping them together, that's useful models, and this will be left to physics. But what we should also do over here is do, oops, no, I meant, is do atoms and not group them, only add them one by one and explain every single one from the quantum physics point of view. That would need messy stuff like its utility or stuff like that. No, that would be left for high abstraction and for models. Oh, it's chapter 4.10. Present that's our book. Oh, there no. Well, okay. Bit disappointing here. Because we are on chapter 3. I'm here, same book. Because there's no 4.10. That is not the same book, is it? It does look fun though. quantum physics. Ah. And this is actually correct, not unlike the screenshot that I sent. Well, obviously it is correct, that's obvious, right? But look at that, it is lowercase psi, which means it is actually, because Hamiltonian operator is, when applied on lowercase psi, is actually equal to energy. Yeah, that's correct. I'm just saying it because recently the screenshot of someone's had an uppercase psi over here, which was incorrect. It's the way function. Now, okay, so there is a meaning to it. When it comes to quantum physics, which is great. That's amazing. It's a relief, a huge relief. It is a huge relief that there is a quantum physics system to it. Great. So there was the way to do it in quantum physics, and that's sick. That's wonderful, amazing, great, grand. Now, I don't know what I should do right now. I'm not gonna lie. I do not know what I should do. I'm trying to detox some coffee again, and because of that I can't really focus on anything. I'm tired, very, very tired. We could do one thing. Well, that is off. We could look for one thing. Blender, visualizing, clouds, because what did minute physics use for this?
Think.
I mean, what engine? I know these. Is the source for what Netflix is used for this? Just wondering. Because I could do them in Blender. I probably should do them in Blender. Here's the thing, in Blender there are geometry nodes, which means I could electron clouds, which means I could create a project for visualizing electron clouds based on a shape, which would look like this. First of all, we add a general shape, and now we take geometry nodes. Now what we would need is particle wave duality. It's quite a thing to visualize. I'm not minute physics. Minute physics is objectively better than me, so I'll have to dumb it down for myself. The biggest problem is that there is actually kind of nothing to visualize. That okay, I dislike being a basic bitch in this case, but there is nothing to visualize. Obviously, you cannot really see electrons. You cannot see the wave particle duality, because that's not how it works. It's a wave and the particle at once. It behaves it behaves like both, which means you can really visualize that. Also means that for a single electron, oh, that would be a preferable way to do it. For a single electron, showcase that actually might be doable. Okay. So here's the thing. We'll add UV sphere over here. Then we'll call that, this will be our electron. And we'll also add a new collection 2, fine. Inside this collection we'll add new collection which is called electron. And we'll put the electron into the electron, just like so. Now over here, actually geometry. Info, we have, object info, we can just use object info that. Like this, and geometry over here, and this will be electron. Sick. I don't have to mind about that now. This is our electron. Now, here's what we're going to do. Transform. Combine. Well, RGB doesn't really matter, but XYZ would be more correct. And now we'll have a value. There we go. And math. Have division. Over here, 1 divided by that value. Right now it's 0, so let's increase that. And the thing gets smaller as we increase the value. Great, exactly what we needed. Now we have this. We can use these geometries to instead do it differently. So we will take and points. I wasn't looking up. Search points. Points to volume, no, volume to point. Oh, but we have points to. We have points to volume. Oh, that is actually great. First of all, points. What's the thing? Instead of points, distributes points on not on faces. Mesh the points. How would that work? Point instances to points. There we go. No, points to instances. Oh, point stuff. Instance on points. That's the way to do it. There we go. And this is our geometry. Not quite. I need by the volume. This is doing it on the mesh, which we could achieve also this way. Which means it's not doing it. It's doing nothing. No, we need to put them based on points to volume. Damn it! There's volume over here, by the way. I can. This is rather dull, though. Wow, that is really taking up some serious GPU power. Okay, how's this one going? Oh, it render ready. Oh, that's so wonderful. That's actually quite what I needed. I hope it did render at least. Alright, so now we just have to figure out how to make this work. which means Blender points on volume geometry nodes. This is not a real thing. Distribute points in volume. This is not a real node. Unless I don't have the 3.1 Blender. Which Blender do I have? Blender 3.5. I might not. There is a possibility that I don't have Blender 3.5. Let's quickly. Is the .msi file? Okay, well, yeah, all right. May contain viruses. Yup. Wait, is it going to download Blender? I would just like to update. Yup. Well, I have two blenders. That's a good question. So then I might need to uninstall one of them. I think that would be a reasonable choice. Okay. 3.5. Oh, that looks different. Wow. Save new settings. Okay. Wow, that looks. It might be a minor change for most of you, but for me, it's wow. I'll have to get used to this. Okay, what's insane? New election clouds. Yep, and points on volume. In volume, yes. Obviously, you have to input volume. Mesh to volume. Yup, sounds reasonable. And up to density. Beautiful, look at that. Now, all we need to do is just change the density. Blender geometry nodes distance from the origin. Is it called the origin? I'm pretty certain that's what it's called, right? Set origin, yeah. Distance from the origin. Now. Oh, that's a rather nice solution. I like that. Which means we will need texture coordinate? No. Not quite. Not quite. Not quite a texture coordinate. I want them to be more scarce further away from the origin. closest location to the target geometry. Not quite what I'm looking for, is it? It's exactly, it's this. Okay, I suppose there is one way I could do it, I suppose. Which is go to shading. Oh, this bar looks off. And over here, new. Actually, not quite, I suppose. Or actually, maybe, yeah, new. Electron cloud. And what we could do is we could do emission. Mix shader. And now texture coordinate. Let's hope that this will work. We need math nodes, 3 of them actually. Square root over here. Subtract over here. And object in dot product. Unless dot product will be only in vector math. Like over here, dot product for this case could make more sense. Now over here, obviously we'll need to go to the geometry node. Oh, that's different icon, I like that. And now texture. Actually, material. Nope, actually, material. Set material. This and electron cloud. Yes. I have no idea if that worked. Okay, in the example, looked like this. Color ramp. Let's do it from red to yellow. That's alright, great. Is it because it's negative? It is, and the color... Oh, is the color uniform or is it... It's hard to tell. There's one way to tell. It's to multiply by some upset value. Which jumps. It's uniform. For sticks. So it doesn't work. Wait, this example makes no sense. There's square root and square root has 2 values. What? Is it? Oh, this is not a square root then. This is add, multiply, 2 of them. Over here, this is actually, yes, add, and add to this, and only this root, and root over here. And that still changes nothing, great. Sick. Uh-huh. It worked. Oh, it worked. Oh, it worked. Oh, it worked. Okay, we should do it this way though. Okay, red starts 0. Yes. 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 Now we should normalize this. Because the issue is that if we make this bigger... Well, maybe we don't have to. Somehow it works. But yeah. Oh, this is exactly what I was looking for. Oh, sick. If we increase the density, there'll be more of them. Oh, that is great. Should be as small as possible. It should be as many of them. I know that I'm frying my GPU and CPU right now, but I mean, can you blame me? Oh, that's great. Now the thing is, we won't be using it like this, we might, but we also at the same time will do transparent BSDF, and we'll use this like so. That didn't work. Why? It just goes straight to black. Maybe it's just a glitch caused by Eevee. What are you doing here? You know you're not supposed to be there. Why should you compute dark? Okay, I don't have time to get into it. Oh, maybe it's a new graphical engine, and I'm just an idiot who used the old one. There is a possibility. At the same time, these should be getting more and more. Okay, they are transparent a bit. Just these ones are. Oh, it's going the other way, which means this should be the way to do it. Yes! Oh, that is sick. Now divide by... Actually multiply by some number, looks like this, maybe? Oh, that is... Well, actually, I don't think this multiplication is even necessary. It won't be this. Let me just increase the red. Oh, yes! I mean... Okay, that's... I think I overdid the multiplication, that's not necessary. I think if anything we should add a bit to it. We should actually probably... Oh wait, subtract. Yeah, so we should probably subtract and then divide, because that will average it out more. Multiply, not divide. Oh, and then now it's negative. Now divide. Divide makes it more average. There we go. Adding in this case would be less confusing. 12. Nope. 6. Let's do 3. Okay, let's do 1.5. Yeah, looks good. So there we go. Now, really neat thing about this, a really neat thing about this, a really neat thing about this is that these are geometry nodes, and you know what that means. it means that we can add any object. Let's use the monkey head. It's the usual example of a complex object, and we can go over here, apply geometry nodes. Where's them at? Where's them at? Geometry nodes. And it breaks instantly. Why? Oh, why did it break instantly? Is it because I did not... Okay, it's because over here we need to do electron cloud. And it didn't work. Why did it break instantly? Works for this. Oh, it's because... I think I know why. Over here it should be self. Object info self blender. This will be really convenient because I'm doing a lot of stuff with atoms, right? A lot. Okay, it's simpler than I expected. Just self object. A lot of stuff with atoms, and I up to this point didn't have a good visualize. Modify object. What do you mean? It's just. Wow, my my GPU did not like this. How about sphere? Oh, my GPU really isn't liking this. Oh, what happened? I have to go back. Oh, my GPU really hates that. Ah, I can feel it. It's fighting. Fighting, stay alive. We can't have that. So over here it works. Now self object. If we input self object, it breaks all of a sudden because can modify object. But if over here, oh, because it's electron, it's not itself. If we do sphere, it has a problem. But if we do electron, there's no issue. The only problem being that electron, if anything. Oh, maybe I was changing the wrong one. Oh, I was changing the wrong. I'm such an idiot. I'm such an idiot. Okay, so the distance. Oh, the distance. I'm such an idiot. It's over here. And it's an object. And this. I should just delete this and just. From instance. Nope, object. Can I not do it self? Can I really not do it self? It has to be something. Like sphere. But wait, then if I put it over here, shouldn't it light up the Suzanne? Shouldn't Suzanne get lit up? Like if I... Oh, it did! Oh, that is... Okay. Isn't that... Okay, that is kind of cool. Look at that. We should probably go over here. Location, rotation. Location, rotation. Okay, I'm trying to think of how could I use that. I could use it. I could have a single object. Oh, that's a great idea. I could have a single electron object, which basically means just a single ball of all of these. And then all of these colors would be based on different electron segments. Segment? No, shells. Yes, shells and subshells, which would be huge. But at the same time, it would be fun. Is it a good idea though? Because in this case then, first of all, we should get this over here, and second of all, if we try and do it fun way, then we probably shouldn't do it based on sphere, only on the electron, because that's more of a constant shape. And now, well, I suppose we could do the subshells. Okay, this, we should separate stuff so that we won't get lost. This tells us the distance from an object. Let's delete Suzanne. Let's add the usual sphere. First of all, let's do it like this. Now, when it comes to the color, for now, let's use normal borrowing. Normal borrowing color, and that's because we could showcase with color what sphere belongs. Okay, so now here's what we'll do. Clamp. Where's clamp? Not seal, no, we are actually, wait, let me just talk about it here. Not seal, we are looking for wrap? I don't think it's wrap. Snap? No. Maybe this wrap. Maximum 1, minimum 0. Ah, it's not wrap. No. Ping pong? Every other cycle, maybe. No. Hyperbolic tangent, I suppose, could work. Kind of. Because the maximum value will be 1 then. But I mean, well, then we would have to multiply this by say value like this. It's good enough. Now what's important is that we have it normalized. Why is that important? Well, it's because let's brighten it up a bit. It is important that we have it normalized because now we have it normalized, it will be between 0 and 1, which means if we go over here and add multiply, like a lot of multiplies, right? Multiplying by 1, that's changing the thing, but multiplying by itself will not lead to any weird effects. So what we can do right now is we can add multiple objects, which basically means this is so far comparing it to the election. Should not be election. Election should stay here. Now what we should do is we should add new collection, shells, and this is where the pain will start. This is where the fun really starts. Because you see, we need, okay, electron shells and subshells. We're looking for all of them. Or just electrons. Yeah. We should mold them though. We should. subshells. This basically represents the probability of finding electron at any place, with more transparent being less probable, and at the same time considering also you have to counter for the fact that my GPU is only, you know, as good, so I cannot just add zeros over here forever in order to achieve the optimal look, because yeah, this is more probable than, right? This is more like actually look like, but my GPU can only take so much, so not doing that. Also at the same time over here I shouldn't use electron, because that's idiotic. There's an idiotic way to do it. Where is it? There it is. In order, instead let's use an icosphere. Preferably with only one subdivision, which up close may look weird, but it will save up a lot of resources. So we can now do 3. There we go, and still it's fine. Now we need all of them shells and subshells. It's orbitals, that's what it is, obviously. We have this, which is good. You have to model all of them.
What do you got there, dear? Well, just some stuff for a Halloween party at school. I'm a treasure. Oh, I didn't know you were gonna have a Halloween party at school. Well, we're just gonna dress up and play some games. Oh, that sounds
I don't like the fact that this will be very manual later on. I'll have to do a lot of things manually in order to change it for different atoms. But at the same time it's good base. Because based on this, here's what the basic idea would look like. Over here in shells, we should add it's a good example. Right, atomic orbitals visualization. Not quite what I'm looking for. Where from? It's neat. You are kidding me.
Wait a minute, where are we going?
You.
Oh, to the party.
What can I not? There's just. I love the internet. You mean to tell me there's just. Wait. I can just download this. Notebook system. That's a bit worse. Because I don't have that. Ah, damn it, I genuinely thought there was just 2. Upsetting. You cannot just give me hope like that. Oh, that is also... All these are applications. Why? I'm just looking for some images. This is insane. Oh, this is up. This is and so it's 3D. That's insane. N is equal to 1. This is insane. This is exactly what I'm looking for. Complex of those physics. You are not real with me right now. We have 2, then we have 3, and we have 4. Well, okay, I can see the pattern here. Okay, I can see the pattern. Okay, over here we have different. Okay. Okay. There we go. Alright, fine. So we have to first get the appropriate end. Okay. I mean, this tool actually is... I'm speechless. Wow, I love the internet. Just things like these out there. I always love these pages with absolutely no CSS, only an extremely good example. One of them, which I use surprisingly often, is this imaginary function hosted on GitHub. Graphical calculator? Surprisingly handy, yeah, hosted on GitHub. It's sick. Here you can see the sign function with complex input output. This is a sign function. This is what it looks like. Fun, right? Alright, but for now, okay, this is great. I should already tell that the bottleneck of this will be me, definitely. Tool is great. The thing is, we should make one for each NNL. XY, okay, so. It feels upsetting that I'm the bottleneck in this case. Alright, make it, quit playing with that. It's not a toy. It's not a toy, okay. This is a decent visualization. Fine. I can do these manually. Auto smooth is also here now. Oh yeah, I should have updated my Blender quite a while ago. I think I was using 3.1 still. Well, now the electrons clouds and them, right? Does them electron clouds I guess that'll be it for this issue. I'm off to finish the video. For tomorrow, I am not prepared at all, unfortunately. Well, I am prepared, I'm not prepared enough. I also have to record for a video that'll be live in 3 weeks. So yeah. Thank you everyone for watching, and have a great day. Bye!